welcome to Live Coding with me, Rachel. I'm Rachel. Does it say Live Coding? Yeah, it does on the YouTube title card. Welcome. Today, we're going to be continuing on a project we've been working on for a while, and we'll probably continue to work on for some time because it is not done yet. So the overall project is a conversational assistant that will give you a dialect quiz. So ask you how you say different words, and then take all that information and run it through a machine learning model trained on a bunch of people from the United States answering the same questions, and tell you where in the US it is your language usage is the closest to, if that makes sense. Pranav says, after training my classifier all day in the office, I will now sip some G&T and watch someone else train their classifier. Cheers. I have coffee because it is 9 a.m. for me in a humorously big mug. It's very large. So that's the general idea of the project, and so far we've built the outline of the assistant using Rasa open source, hence the channel that we're on, and we've spent the last couple of weeks doing data cleaning. So we got a really large data set courtesy of Bert Vaux from the a really large data set courtesy of Bert Vaux of responses to the Harvard Dialect Survey. And it has, each column is a question. The questions were multiple choice, so this is the index of the response, which is 1 indexed, not 0 indexed. And then the first couple pieces of information are the participant ID, the city that they're from, the state that they're from, and their zip code. And from here, I believe, is where you spent the ages of 0 to 6, if I'm correct about that. I could be wrong about that. I don't know the exact phrasing. But this is the same data that was used to train the New York Times dialect quiz. And we went through and got only the questions that were A, in the New York Times dialect quiz. So it's like 130 questions, 120 questions. We were chucking out most of them and only asking 19, which is 6 less than the New York Times dialect quiz. And we went through and picked out those by hand and figured out which question went with which text. And then also for the answers, what the order of the answers was. So here for question 10-8, do you pronounce caught and caught the same? You maybe can tell I don't. Those are not merged for me. We had 2 options, 1 and 2, and in our data set, we just had the numbers. So, all right, thank you. So we went through and did the creation of this file by hand. And then we merged it with our other file. So we had, for each question, the actual text of the answer that the person had given, and then their city, state, and zip. And Wednesday, Wednesday of this week. Sorry, it feels like it's been a month. There's so much going on in the world right now. We went through and where's our IPython notebook? Here we go. We narrowed down the number of cities that we were looking at. So there's something like, I think, 11,000 zip codes represented in the data set. There's closer to like 40,000 zip codes in the US. We figured all this out last week with some judicious Googling. And I decided I didn't actually want to do zip code. A, because if I tell someone who's not from the US a zip code, that's not super meaningful. And even if I did tell someone US a zip code, that would not still be very meaningful unless it's one that's actually very near where they are. So like you could tell me a random zip code and I could not tell you where it was from. I'm Alone Always says, how to forward user query to custom action server without modification. So you want the whole query. I think you can do that with the handler. So this is in an assistant using Rasa, taking the information that the user passes on and passing that on to another server that is running some code, any code that you like. RSTK is in Python by default, but you're welcome to run anything you like. And I'm just going to pull up the page that I think is the appropriate doc page and show you the URL, and then move on. If I can find it quickly. I can so I would probably go to, oh, that's very small. I'd probably check out the action server page and see if you can find more information there. And if you cannot, then I would ask on the forums. So this is in the Rasa docs, rasa.com/docs/rasa/API/action-server. So this is where you will find more information on that. Ankit said, can we set web chat height and width? I have no idea, my friend. That sounds like a forum question. Yeah, I am probably not the best person for front-end questions. All right. So we have our data set. We're trying to figure out what we want to predict, right? So if we look at our data set here, we could predict zip code. We don't have good coverage in the United States. And if I tell somebody a zip code, that's probably not going to be super meaningful to them. We could just say state. States are probably a little bit big of an area. So just for example, in Washington State, which is where I live right now, Seattle is pretty distinct from like Yakima or Spokane. And if I told someone, you're from Washington, and they had, let's say, Yakima features, there's no questions in here that would distinguish Yakima from Seattle. But you could imagine extending this to include more dialect features. That would be, I think, fairly unhelpful for people. So Ankit said, not a problem. Yeah, sorry. I can't be more helpful there. On asking about the resetting height and width on the web chat. So what we ended up doing was looking at combinations of city and state. You want the combination of both because otherwise they will be ambiguous. So for example, Portland, Oregon is different from Portland, Maine. They are very far away from each other and very different, but they have the same city name, but not the same city and state name. So that's what we went with. And from there, I think we had a lot of examples, but a lot of them were also unique. So there was only one person who had filled out the quiz that had a specific answer. So I don't know if there's anyone else from... Oh, yeah, okay, so it looks like Chelmsford actually had quite a few people from it. What about Morton Grove? All right, so it looks like we only had, for example, 2 people from Morton Grove, Illinois, fill out this particular quiz, which when you compare to Chicago, we have a lot of people. So I'm just looking over at this bar over here, and it's showing us a preview of the file, and if there's light next to it, it means that the thing that we just highlighted exists in there. So Western Massachusetts, you can see we only have a handful. Pacific Washington is a good example. We only have one of these. So if we have a lot of classes, many of which only have one example, we're probably not going to have a lot of success putting people into those classes. Also, very surprising that someone from the Pacific Northwest would say Ewans. A lot of these are actually pretty surprising that someone would say Ewans. I'm suddenly worried about our data cleaning, y'all. I'm suddenly pretty worried. So yeah, we might have to come back to that, because I'm guessing that that's actually supposed to be you guys. And that we have matched the wrong answer to the number in the file. Yeah. Jackie says, can you suggest how to start making a chatbot from scratch? That's a big question. I would say start with example conversations that you would like people to have with your chatbot, and then work from there. Also, the Rasa way is to build a minimum viable chatbot as soon as quickly, and then try to get it in front of testers as soon as possible, so you're not working with a bunch of sort of data that you've made up, and you can start adding in data that's actually produced by humans using your assistant as soon as possible. Especially synthetic language data tends to be funky. Very funky if it's machine generated, and still like a little bit funky if it's human generated. All right. So, potential problem with humans being well overrepresented aside, we decided to go with a combination of city and state, and also to filter them based on only cities and states that showed up quite a bit in our training data. Specifically, ones that showed up more than 15 times. So we started out with about 47,000 rows, and I think we ended up with like 2,600 rows or so after filtering on these conditions. So we lost about half of our data, but still fairly large data set. I think we should be okay. And as I remember, we had about 400 classes, which is still quite a few classes. All right, so I'm just importing in my libraries, reading in my data, doing some tidying up. So we remove punctuation, we cast everything to lowercase so that we can conflate our classes a little bit more easily. We're finding the very common cities and states. And then we are also removing columns from this common cities data frame that will trivially tell us the answer. So we're trying to predict a combination of city and state. We don't want to use city or state as a feature there, or zip code, because all of those correlate very clearly with our target feature. But they're not going to be something that people will answer in the dialogue quiz. So that accidentally training a machine learning model on the answers known as leakage, and we want to avoid that, so I got rid of those columns. And then we did some label encoding. So if we look at, can I get anyone in here? Here we go. So if we look at the data frame before we do the label encoding, you can see that we have the text in here. And if we look at training data after we have I don't know why it's not tab completing. Nope. There we go. And if we look at training data after we've done that, we can see that we have numbers here instead of words. That's important because XGBoost expects a numeric input. And that's the model that we'll be using today. The reason that we can't just use the original data, which already has numbers, is because we didn't, don't show me that again, is because we don't know what a 1 means in this column. So because we have the encoder that took the text and turned it into numbers, we can reverse that process, and when we get our, for example, our answers back, we can reverse it and turn it back into text. So that's why we're doing it that way. I'm Alone says, how to link a web scraper to Rasa chatbot. It's a little off topic. You probably want to do that in the custom actions server, though. All right, let me get rid of this. So now we need to do our test train split, and I'm gonna Google it because I have to do it every time. Scikit-learn. And we are going to be using this scikit-learn model selection function. Let's pull up the docs just real quick. Just real quick. Example code, please and thank you. Why shuffle false? Oh, that's right, that's right. So we need to split 5 to 10 characters. Oh, I see. Okay, so we need to pass in a data frame and so a data frame is a tabular data structure, and also a vector, and then they'll both be split. So I need to split out my target variable and my testing variable. And while I am here, I am also going to look up XGBoost. On Python. So XGBoost, which is the algorithm that we're going to be using, the library that we're going to be using, has a data structure, has a specific data structure that it uses that is more memory efficient. And I am looking for the example code. Let's just go to the docs. Why not? All right. Also, XGBoost, if you have used it before, just released 1.0, so their first major release. So, congrats to the team. It's an open source library. I really like it because it has very sensible defaults. It's a C backend with a number of different APIs into it. Dart like the framework, like the web framework. No, new type of tree booster. Okay. I was like, oh. Also, I think it looks like there's been a little bit of, tidying up of the documents. These look real good. Python is the one that we are using. Example, yes, please. And we want to do GLM. Probably just the basic walkthrough. I don't remember there we go, there it is. I don't remember the exact syntax for setting up the particular data structure that they use, and it is called dmatrix. Robbie says it's written in Java. Is it? I'm like 80% sure it's written in C. Let's see. Portion system. This is not like a good thing to chase down right now, but if anyone has helpful links about the implementation, I'd like to see them. Python package introduction, install, data interface, setting parameters, training. That's what we're doing. And specifically, I was looking at the dmatrix. Here we go. Okay, so this is what I'm looking for. So we need to split the data and the label, and then we can cast them to our training matrix using xgb.dmatrix. So this is, I'm assuming, how they've imported the library is as XGB. Okay. And actually, I'm going to go back then and change my imports as well. So that I am following the docs. XGBoost. All right. Run that real quick so we have a different alias. Should we do they do their test train split after or before? CSV file, NumPy 2D array. So my question is if they will do the test training split during training, or if we need to do it ourselves beforehand. And I vaguely remember doing it myself beforehand. But again, there's been some updates. So I want to make sure that I am still following best practices. Also, you'll see here that you can save your model and then load it in later, and that's what we'll be doing in our action server. So I will have the model, I'll use that for validation, for prediction. I'll validate it ahead of time, and then use that for, yawning, goodness, and then use that for our actual skill. Okay, so I'm pretty sure that they are doing it ahead of time, and then we will have our validation text elsewhere. Oh, and Pranav is also saying beforehand. Thank you. There's a little bit of a lag, so I'm not ignoring you. All right. So we need to. I'm going to follow convention and say. First of all, I'm going to remember what language I'm using and then do the right thing for that language. And I'm going to follow convention and call... Yes, that would make sense. I actually want the data frame. And call the target variable y class target, and all of the training data let's see, drop column pandas data frame. It's drop. Noted. All right. Sorry, I'm just Googling how to do things in pandas. df.drop columns and then the name of the column. All right, so I'm going to copy this, dot drop, and then columns, no space because we're using Python, and then name of the column. So class target not defined. Oh, gotcha. It's got to be a string. All right. And now really quickly just look at the head of X. And yeah. All right. I think we're good to go. Fantastic. So we have separated our target variable Y from our input variables X. And I'm Alone says, can we extract the code from the existing model for modifications? Not really. So you will know what code was used to train it, kind of, because it will just be xgb.train. But a machine learning model is a combination of the code and the data that was used to train it. So to change a machine learning model that you've trained using the same algorithm and the same hyperparameters, you actually change the data itself, if that makes sense. It's a little bit different from other types of software development. Yeah, hopefully that makes sense. Vijay says, if I'm not wrong, you can simply follow the sklearn API format in XGBoost. No need to convert the data to dmatrix. Yes, I believe that you can, but I want to be using the dmatrix because this is a medium-large data set, and it should be much faster. And also, if I do the conversion, Well, you know what? This is a benchmarking question, but my gut instinct is that if I do the conversion, it will be faster at inference time, even with the additional step of doing the conversion. And because someone is going to be waiting for the bot to tell them what their answer is, I want to try and get this as snappish as possible. So I might end up not using the dmatrix format. I don't know. We'll see. Pranav also uses the sklearn API. Is it, because I know that XGBoost will take in just a matrix, but will be slower. Is that what it's doing, or is it actually doing the dmatrix conversion for you? For now, I am going to stick to using the dmatrix, I think. Hey, Siobhan. Because... all right, so this is going to be the next step. Because that's what they're doing in the docs, and I tend to believe that the docs are going to be the most efficient thing, because speed is one of the main focuses of the XGBoost library. But I'm willing to change my approach. Let's get it working first. I might end up not using gradient boosting at all. I might end up going with a nearest neighbors model, because we got a lot of classes. I can actually tell you exactly how many classes we have. 415 classes, each of which has at least 16 examples, but that's still that's quite large. That's a lot of classes for what, 26,000 rows. Yeah. Actually, what is it? Dim? Is that Python? Nope. Shape? Yeah. 24,000. So not tiny data set, but still like a little bit on the, for the number of classes we have, a little bit on the parsimonious side. All right. Peace out. Okay, so now I need to do my test train split, and as I remember, I had everything is closed. I can't see a dang thing, and that one. All right, I don't know what I accidentally clicked, but it was not the correct thing. Also, you got to see my desktop background, which is Dolly Parton right now. All right, so the next thing that we were gonna do, where is my, okay, well, I've just, wherever my tabs with my Google searches are, they're just gone now. So I'm gonna look up how to do test train split with scikit-learn again for like the 2000th time in my life. Sample code. All right. I'm just gonna do this. So the reason that we want to split our data into two, I know there's a variety of people on the channel, some of whom have a really good machine learning background, some of whom are newer to the field. Welcome to machine learning. So the reason that we split our data here is because we want to, what the heck is up with this indenting? I guess that's just line wrapping? Weird. Don't like that. Is because we want to be able to tell that our model is doing a good job of learning patterns that will extend to, that our data is doing a good job extending to novel patterns. So what I mean by that is, in machine learning, we learn from example rather than rule. And if I have seen all the examples that are available to me, And then I look at some of those examples later on to see if I've done a good job predicting. Because I've already seen the answers for those, I'm basically cheating. So similar to linkage, if I already know the answer, it's hard to evaluate. So I'm going to take some of my data, squirrel it away to the side, and then later I'm going to run my prediction model on that data and see how well it does. So that data that we do know the answers for, and we want to see if we're getting the answer as well. All right, so 25 is still a lot. Honestly, I'm going to go with 10%. So this means that I am going to set aside 10% of my data for testing, which is, that's like 2,000 cases. That's fine. That should be good. We're probably not going to have excellent coverage over all of our classes, but I'm okay with that. And then this is a random seed, so when we do this test train split again, we will get the same split every time. All right. And then for detrain, we want xtrain as the data, and then the label is ytrain. And just by convention, y is the thing you're predicting, x is the data you are using to predict. And I believe also I will need to do, let's just do a separate one for testing of the data, the testing data. And instead of xtrain, it should be xtest. And instead of ytrain, it should be ytest. Excellent. We're good to go. Let's actually do the training in a separate cell, so we're not we are not, what's the word I'm looking for, rerunning all of our test train split every time we train our data set. All right, peace out. And because I lost my tab, I have to go back to the XGBoost docs. Come on. There we go. And we are training. And I'm just going to use the default settings. One of the things I really like about XGBoost is that it has very sensible defaults. So that's what we're using. Pranav says, for my ACL submission, I reported my model results on 20 different test train splits. Reviewer 1 said that I tested my models way too much, lol. Yeah, I'd say that's more of a, that level of cross-validation is more Kaggle-y than, you know, academic research. Yeah, I'm not going to be doing quite that much testing, I think. Right. And parameters. Okay, so this is where we can set the, open you in a new tab, the qualities of our model. And let's check out the parameters for here. So, like I said, the defaults tend to be pretty sensible, but we can go through these real quick and see if there's any of these we want to change. So this is the sort of the learning decay rate. Update. Yeah, so if your step size is shrinking, that's learning decay. Oh, no. It shrinks the feature weights to make progressive boosting more conservative. Okay, yes, it's also just the learning rate. I don't know why I didn't look at that first. So this looks like the Greek letter that was used to represent it in probably the paper, and this is the name that a human would call it. That's not fair. That's the name that probably a machine learning engineer would call it. Minimum loss reduction required to make further partition on the node leaf of a tree. So by default 0, you will never split the tree unless there is, so you will split a tree, you'll create a new branch if there is any information gain. which is sort of the default for how decision trees work in general. Max depth is 6. We honestly might want to go slightly above 6, to be honest, because this is, I'm going to say honest a couple different times, because this is a pretty large data set. There's a lot of features. Well, there's not that many features. There's 19 features. I might go up to, I guess try it with 6 and then try it with 8 and see if that changes anything. Minimum sum of instance weight Hessian needed in a child if the tree partition step results in a leaf node with sum of instances, blah, 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 blah. Okay, so this is just how far, so you got little leaves going down, what's the minimum number of instances you need in a leaf in order to keep going. Maximum delta output. Okay, might help in logistic regression when class is extremely unbalanced. I don't think our classes are that unbalanced. I think we have like a 10x between our biggest and our smallest class, which is not super big. Yeah, you can get like several thousand times differences between classes in very imbalanced or very sparse problems. So this is not a super extreme machine learning problem. Subsample, sampling method, I'm okay with all of these. So the one thing that we might change so far is tree depth. We'll try it with 6 and then see if it's, if we need to go deeper. L2 regularization, L1 regularization, tree method. By default, it will use a heuristic to choose the fastest method. I'm fine with that. Leaf, process type, and these things are going to be, I think, more specialized types of parameters with particular families of tree methods. Okay, excellent. Yeah, for now I think I'm probably pretty good with those default parameters. So you can see here they've set the max depth to 2, so this is going to be a very shallow tree. Eta, which is learning rate, is 1. So was it learning rate or learning rate decay? Benjamin says, hi, what's the best way to really learn Rasa really good? Build some stuff. That's my suggestion. And when you run into trouble, read the docs. Well, I'd start with the docs. And then when you run into trouble, read the docs and ask in the forums. And as soon as possible, get your assistant to the point where you can start having trusted testers have conversations with it. All right, probably not gonna do multi-threading. We'll just keep it on the CPU. And then evaluation metric area under curve. So this is going to be a multi-class classification problem. And prediction plotting. What are the different loss functions that you allow? Let's look through the code collections. I think that'll be helpful. Random regression, generalized linear model, evaluate results, examples, parallel. Let's check the basic walkthrough. I think that's going to be our best guide. Binary logistic. So logistic regression is separating into categories. Linear regression is predicting a value. All right. Do we have other examples? Yesterday, because everyone in Seattle is working from home, and I live in an apartment building. I usually work from home, so it's no different for me. But I've definitely noticed that the internet during the day is a little bit more crowded. What was I looking at for? XGBoost multi-class. Yep, that's what I want. Oop. and we have an R version and a Python version. So let's check the Python version. What loss feature are you using? Softmax. Okay, excellent. So I'm just gonna use this. That'll work. Yep, sorry for that disruption. It's gonna make my life rough, because it means that I'm gonna technically have done 2 streams today, so I need to futz with stuff. All right, so, nope, I need to create a parameter first. How do you do that? And I believe in their walkthrough they did it, yeah, like so. So I think we can do that. And then it is, and then objective is multi-class softmax. All right, and for now we're not going to deal with the depth at all. All we are going to do is train. And I do need to, I'm probably not going to specify a watch list. I do need to say the number of rounds, and I think I'm going to do, it's a fairly large data set. It's a large number of classes. Let's do 10 rounds of boosting. That sounds fairly good to me. Oh, an error. Number of output classes. Value 0 for the parameter number of classes should be greater or equal to 1 num class number of output classes in the multi-class classification. All right. Yep. Where are you specifying this? Aha. All right, so we need to specify the number of classes in our parameter. And it was what? Num underscore class. Num class. And the number of classes that we have, I'm going to check something really quick, and I'm going to check that we have this. So 388 in test and 415 in target and 415 in original Y as well. Okay, so we're not going to be evaluating every class, but I believe every class should be represented in the training data. So that was my worry. We are good. It's probably handled, what did I just say, 415? It's probably handled in the scikit-learn test train split, but you know, never hurts to be extra sorry. All right, so and I am seeing everybody in the chat, excellent. So the thing that it is doing now while it's thinking about it is, the way that XGBoost works is it's a type of gradient boosting. So you build a tree model, you look at the errors of your tree model, you build a new tree model just on the errors, and then you continue to do that, in this case, for 10 rounds. Raj says, hey there, how are you? I'm doing pretty good. Yeah. I got my coffee. Okay, models trained. Pretty quick. XGBoost is fairly fast. Let's XG test. You know what? I'm going to redo it. I am going to include the watch list so that we can have results as we go along. nope, 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 nope. Cancel. Well, we'll survive. Except we've called it dtrain instead of XG test, and we've called it dtest instead of XG test. And then watch list. There we go. What if you stopped? Excellent. So what I have done here is that I've said, hey, while you're doing this, as you're going, I want to see how well you're doing at classifying things on the in our training data set, as well as your testing data set that we set aside earlier, so we can validate as our model is training. And I was expecting that to print out as our model is training in a output below the cell, and it's just sort of not doing that. I wonder if that's a VB code thing, maybe? VB code, VS code. Excellent. From here, we are going to do testing, and this is going to be pretty much exactly the same for us, so. Oh, interesting. Okay, so they've changed some things relatively recently, so I'm just going to take all the prediction code, peace out, and stick it in a new cell. First, I'm going to fail to copy and paste well. And we probably aren't going to need all of these predictions every time, but I want to know sort of generally how well the model is doing. Okay, so we are going to take our trained model. We are going to predict the classes of the D-test dataset, which also includes the labels. So we're going to find out if that worked. And then we're going to calculate the error rate using softmax. And I believe that we actually called it Y-test instead of test Y. So this is the, still can't copy and paste good. So this is a numeric vector that has the correct labels of our output class. And I done made an error. Oh, I haven't imported NumPy. And if you've never used NumPy before, it's a numeric library for Python, basically. 83% error, so that's high. All right, let's try this. So that means that 83% of the time we're wrong, which I guess is sort of, the second question would be, how wrong are we for each of our classes? All right, and this was actually, I believe we called it dtrain. Ooh, excuse me. I don't know why I'm so sleepy. Number of rounds, watch list. Okay, gotcha. So here we are actually training a second model. So I'm gonna actually rename all of these so we won't be overwriting our first model. And I believe instead of XG test, we called it D test. So the difference here is that instead of softmax, so just picking the most likely answer for each of them, this is giving us the probabilities across each of our 400 plus classes, which again, fair number of classes. And I believe this was Y-test, Y-test, Y-test. Okay, this should work. It'll probably take a second to run. What'd I do? Watch list is not defined. Watch list. Maybe I paste bad? Pretty sure I ran that cell. All right. So I'm going to comment out this line so we're not actually training another model because that's what takes a while. Odd that it's taking a while. Am I actually running another cell that I don't know about? I am not. All right. Are you done now? All right. Same error. Okay, I'm pretty sure it is defined though, is the thing. XGB.chain, yes, param, dtrain, num round, watch list. What if I just... I guess I'll just define watch list in this. Am I gonna get the same error? No. Okay, this is what I was expecting. So this tells you the error on the training data, which we expect to go down. This tells you the error on the testing data, which we expect to go down only as long as we are continuing to learn generalizable patterns. And when we start to learn patterns that are only true in our testing data, our training data will continue to go down, but our testing error will start to go up, and that's what's known as overfitting. What does that mean? Cannot reshape array of size, that many, into shape. 2476, 6. Ah, I see. So I'm actually going to... Can I... Series object has no attribute length. Back to Google. Yep, sorry about the flickering in and out. What am I looking up? Get number of unique... Get number of unique values pandas is my first auto correct for that. .NUnique looks like it should be. NUNI, there we go. Fantastic. All right, now we don't have to set this by hand every time. We can just refer to our number of classes variable. Also, given that these were both going down, we can probably go way more than 10. And actually, you know what I said I would do? I said I would increase the depth. Let me look back at the parameter list. What was the tree depth? Booster, silent, verbosity, and threads, and buffer, ETA, gamma, max depth. Okay, let's set the max depth to, let's go to 10 as well. Nope. Yes. So this means that our trees will have more layers of branches in them. And because we have a lot of classes, that's going to give us more power in our model. Yes, I see how that could be. All right, and now we should hopefully get that same type of output out as we did during our model training. Hopefully. Did I do anything different here? Okay, that should be the number of classes. Excellent. So it is going to take longer to train because it's doing more decisions per round. So this should probably take what? We're doing the same number of rounds, but like almost twice as many predictions. Okay, so that wasn't a great improvement in terms of accuracy of our model. But you know what? We'll make it work. All right. So same thing, deeper trees, and hopefully this will work now that I'm giving it the number of classes that we've gotten from our code. So as long as both of these numbers go down every time, we're good. If these start going down while these start going up, we know that we've done too many rounds. They're both still going down, although this one is looking like it's going down much faster at this point. Yeah, I think we could actually probably do quite a few more rounds. And I think I am going to go with soft prob instead of soft max. Because the main reason there is I do want to be able to tell people like their top 3 cities. And if you just take soft max, it'll give you your top 1. And I believe soft prob will give you the probabilities for each of your classes. And let's go 25 rounds. And you can see that our error is identical. And let's do our evaluation in a separate cell as well. And see how this works. Guess and test. So we've tried making our trees deeper, and that seems to help a little bit. And we've tried making our training for more rounds, and presumably that's going to help. We'll see once we get to 10. And you can, of course, parallelize XGBoost. So if I was going to keep working on this for a very long time, I probably would do that so that I can do multi-threading and use a GPU to make my code running a little bit faster. Nope. We done gone too far. All right, so we're looking at 13 rounds, it looks like, is where the inflection point is. So let's do 13 rounds instead. And I believe you can actually automatically do, like, finding that point and being like, oh, that's where we stop, using early stopping. Yeah, so you can see at this point, the error for the training data is continuing to go down. The error for the testing data is going up. And we're not really cracking 80%, which is not great. So what we might do on next Wednesday is try a different method as well. As I remember, the blog post talking about the methods used in this project suggested that they had used nearest neighbor methods, k-nearest neighbors, instead of this, instead of an XGBoost method. And my desire to use XGBoost, so let's try doing this again, just to the elbow point. My desire to use XGBoost is really because you can get feature importance out and be like, oh, the feature that was most discriminative for, you know, this model is whether or not you say y'all or something. But I'm willing to give that up for something that's slightly more accurate, and I'm not super worried about that. The other thing about doing nearest neighbors methods is you can have actually a lot of classes, and it doesn't really matter because you only care about the way that nearest neighbors works is that in your dimensional space, you have labeled for your points, you have a novel point, you look at the n or k, let's say 5 nearest points to it, so you only really care about those 5 near points. And if you have 50,000 classes, but you only have, 4 in that little 5 group cluster, it's not going to change your results any. So did I not change the number of rounds to 13? Thought for sure it did. All right, let's just interrupt it. We should get a model and we can check out, and it should have saved the model. So our test error using softprob is about 84%. So again, I think it's overfitting at that point, which means knowing so much about your tested training data that you are no longer making generalizable observations. All right, so we trained an XGBoost model. I'm not like super happy with it, but what we could do is real quick look at feature importance. Feature importance and feature selection. No, I'm looking for the specific function that does it. This is R. It might be the same function though. We can give it a shot. XGB.importance. Okay. And I probably need to give it a trained model. And let's actually give it the BST model and see what it thinks about that. All right, so the most important feature was questions 94, and then question 107, and then questions 65 and 66. So if we look at our question key, 94, 105, 67, 66. What are we looking for? It was 104, right? Nope, apparently not. 094. So the most discriminative question was, do you say frosting or icing for the sweet spread one puts on a cake? Interesting. I would not have expected that to be the most discriminative feature, but I did at one point in the depths of the past write a blog post about it. I did my own data collection for it. Let me see if I can find it real quick. Yeah, so I did like a very small scale piece of data collection asking people if there was a difference between frosting and icing. And I found that there was a pretty strong difference in age. So older respondents said that there wasn't a difference. Younger respondents were more likely to say that there was a difference. And then that it was pretty regionally bounded as well. So people from sort of Texas to North Carolina, the black states are states I didn't have data for. My data collection was not as widespread, sort of patterned together. And then states out west sort of patterned together, and sort of more northerly states patterned together. I happen to know a lot of my Virginia respondents were from Northern Virginia. All right, that is interesting, and maybe a little bit surprising because I would have expected something like pop or soda to be the most discriminative one. Let's see, 107 was the next most discriminative one. What do you call a traffic jam called by drivers slowing down to look at an accident on the side of the road? I believe is just that question. Interesting. Another one that I wouldn't have expected to be super far up there. And then 65 and 66. Okay, lightning bug, firefly, very much something that I would have expected. And then 66... crawdad, crayfish, crawfish, crawdaddy. They're like little regional use, potentially. All right, interesting. So, I think I do want to know what 110 is. So 110 is the thing that's going to be least useful. What you call the night before Halloween. Interesting. Interesting. So none of them are, not helpful at all. But there's definitely a gradient in terms of what is more and less helpful. Okay. So I think I am, especially given my internet struggles at the moment, sorry about that, I think I'm going to call it here for now. And I just don't think this is the right choice for us at the moment, unfortunately. Because I think this feature plot is super helpful. I'd really like to be able to tell people about feature importance. But I do think, given our really high dimensionality space and the fact that trying to reduce the number of classes meant that we did have to toss out basically half of our data, more or less, we're probably going to have better results with a k-nearest neighbors model. So that's what we'll try next week. And we'll see if I'm right. We might not. We might have very awful results. But one thing that made the New York Times quiz very delightful to people was that it tended to be pretty accurate. So I might, might try to replicate that degree of accuracy, because I know it's possible with just 25 questions. And we do have 19 rather than 25 questions, but I don't think it should make that big of a difference. So, all right. Yeah, I'm going to wrap it up here. Have a good weekend. Stay healthy, everybody. Wash your hands. And I will see you next Wednesday for more machine learning. We'll try a different approach. We'll see if it works better. And I will see you then. Thanks for joining. Bye.